So let's look at the following problem. I want us to prove for every positive integer n, 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over n plus 1 n plus 2 equals n over 2n plus 4. So again, we're going to prove this by induction. So let's start with our outline for the proof. So what is our basis step? You're going to plug in n equals 1 into here. So if I plug in n equals 1, I'm just going to have on the left 1 over 2 times 3. Is that the same thing? Plug in n on the other side, 1 over 2 times 1 plus 4. Those are equal to 1/6. So this is true. They're both equal. And now we're going to do our inductive step. So we're going to assume 1 over 2 times 3 plus 1 over 3 times 4 all the way up through 1 over k plus 1, k plus 2 equals k over 2k plus 4. Again, for some positive integer k. All right, and now we're going to remember what we need to work to, and I'm going to give myself a bunch of space here because I'm probably going to need some calculation room. So in the end, what do I need to get? 1 over 2 times 3 plus 1 over 3 times 4, 1 over k plus 1, k plus 2, is 1 over k plus 2 times k plus 3 equals, if you plug in k plus 1 in your formula, you get k plus 1 over 2 k plus 1 plus 4, or you get k plus 1 over 2k plus 6. So that's what we're working towards. So I'm going to go back up to where we were. And we're going to start with that left-hand side of what we need to show. Plus 1 over k plus 1, k plus 2, plus 1 over k plus 2, k plus 3. So for these first few terms, we can use our formula from up here. So this is equal to k 2k plus 4 and now I'm going to factor a 2 out of that first fraction here in the denominator. So I'm getting k 2k plus 2 . In the end, I need to get down to a single term, so you have to get a common denominator here. And my common denominator would be 2k plus 2, k plus 3. And then I'm going to multiply by 2 here. So now that I have the same denominator, I can combine them into a single fraction. And I'm going to go ahead and distribute in this first term here. So I'll get k squared plus 3k plus 2. And now we're going to factor our numerator. It's going to factor into k plus 1, k plus 2. And you should see that the k plus 2's now cancel. So in the end, I'm getting k plus 1 over 2 times k plus 3, or k plus 1 over 2k plus 6, which was exactly what I needed to get to. So this completes the outline of the proof, and now we're going to write it up formally.